Howdy and welcome back. So we're going to begin with a brief introduction to binary IO in C++. After this lesson video, we'll have an additional lesson video where we'll get into a more in-depth example of serializing and deserializing objects of a user-defined type to a binary file. So binary IO is going to be requested by opening a file with the stream mode std.ios binary. If an input file stream, we have to specify the file that they're reading from, and then we'd also specify that the stream mode is going to be the binary mode as shown here with the second argument to the ifstreams constructor. Likewise, if we'd like to write out a file in binary mode when we're constructing in our ofstream object, in this case OFS, we'd specify the file that we'd like to go ahead and write to as the first argument to this object's constructor, followed by the second, which would specify that, hey, the stream mode here is going to be binary. Now, reading from an input file stream is going to be done using that stream's read function instead of using the extraction operator, which we've seen previously when interacting with plain text files. If we'd like to write to an output file stream or to a file through an output file stream, we're going to use that stream's write function. And this is going to be instead of using the insertion operator, which we had used previously when inserting characters into a plain text file. Now, both of these functions are going to take two arguments. The address to the first byte of the in-memory object, which we'd like to read from or write to, is going to be the first argument to either read or write. The second is going to be the number of bytes of that object, and we'll go ahead and obtain that by the size of operator. And what we'll see here is that if we're reading from a binary file into an object, the address is going to specify the object to which we're going to be reading into. And then the number of bytes will tell us, well, okay, within that file, how many bytes do I need to grab? And then I'm going to essentially pick them up from the file and place them into the object that we're reading into. Now, if we go ahead and like to write to a binary file, the address is going to specify the in-memory object to which we're going to read and write out to the file. So we'd go to that address, we'd essentially take the sequence of bytes from that address to the end, and how we find that is using the size of operator. So we'll take out that chunk and we go ahead and write that representation directly to the binary file. So the first half of this slide is just recapping exactly what we just said. The second is going to be dealing with, okay, that initial address, because the address is going to be essentially an address to the first byte. So the first byte of the in-memory object that we'd like to read or write to. In order to get the address to the first byte of an object's in-memory representation, we're going to have to define this function called as bytes. Now, I don't expect you to understand what this function's necessarily doing at this point. All I expect is that you understand that you have to use it to get the address to the first byte of the in-memory object that we'd like to read or write to. This function is essentially going to allow us to treat any object in memory as a sequence of bytes for read or write to utilize. And essentially the idea here is we're getting away from thinking about something as a specific type and instead just looking at it as a sequence of bytes that we're either going to read to or write to or read from. So how would we write an integer object to a binary file? Let's say k file name is some constant for the file that we'd like to write to. We're going to go ahead and open that file in binary mode. And we have this integer object I that we'd like to go ahead and write to the file. We'd go ahead and use OFS's write function. We'd specify the address to the first byte of I. So we'd simply say as bytes and pass in I. And that function that we essentially showed you on the previous slide will return the address needed to perform this operation. So at this point, we know where we're going to go out to memory and start reading from. And then we know where we're going to stop based on the size of the object that we're going to read. So in this case, let's assume I is 4 bytes in length. We go out to the first byte. We go ahead and write it to the file, write the next one, next one, next one, until 4 bytes sequentially from that starting address are written to the file. So we've got that object out to file. And I guess the first thing to kind of point out here, minus my little mistake on this slide, is going to be that where we're writing in the file is going to essentially be dependent on where I guess we could use the term pointer, where we're currently so there's going to be this mechanism that's going to keep track of where we are in the file. If we're putting characters, we'll see that there's essentially a put pointer that says if we're inserting, it's going here, and that would specify okay. In this case, if we're inserting I to the file, we're going to do it at that point. If we're reading from the file, there's going to be an additional pointer, which is essentially specifying in the file stream where we'd start reading from. So, and we'll see here, we can manipulate where those are if we want to read or write to a specific location within the file. So let's just assume that this integer was placed in a brand new file. It was at the first 4 bytes of it. Okay, we've written now we want to read it back into memory. So assuming, and again, in order to read from a binary file, we have to know the format of the file. In this simple toy example here, the file is simply just a single integer value. To read from it, we'll go ahead and bind IFS to the file, same file we just wrote to for this example. We'll specify, hey, we're going to open that up in binary stream mode. We'll have to specify an object that we'd like to read into. This is no different than when we were using the extraction operator to pull things out of, say, CN or from input file stream when we were using characters in plain text mode. Here, the only difference is that opposed to kind of doing all this stuff behind the scenes to deal with the conversion of those characters into the proper type, we're simply going to begin reading from wherever that pointer is that's telling us where we're reading from the file, size of int number of bytes, and we're going to take those bytes and we're going to drop them into our integer object I. So if we had, say, 4 bytes encoding the value of 1, those 4 bytes would be taken directly from the file and dropped into I. So I don't know, this is kind of a silly example. Let's say we have file.dat, that's in memory in our program. Let's say we have I. It has some sort of starting point, some sort of ending point. Let's say within the file, there's the first 4 bytes and it's encoding some sort of integer value. What this is going to do is, assuming that we're saying we're reading from the beginning of the file, we'll grab those 4 bytes, we'll take them, and we'll just drop them into this integer object. And the same thing's going if we're going the other direction. If we're writing to the file, we simply go out to our integer object, grab those bytes, drop them into the file, wherever that pointer is in the string, specifying where they should be dropped. So whenever you can, read and write files from the beginning to the end. Well, and this is Strustrup's advice from his Principles of Programming and Practice, is it's always going to be good to read from the beginning to the end. It's just going to make things easier. When modifying a file, it is often going to be best to produce a new file containing the change. This is what we did in our plain text file example using the CSV format. However, what we can also do, whether we're in plain text mode or binary mode, is through positioning, we can select a specific place in a file for reading or writing, regardless of whether we're using character-oriented I/O or binary I/O. Every file that we open for reading is going to have a read get position, and that's what I was talking to with this about this pointer on the previous slide. It's specifying that, hey, if we hit the stream with the read operation, we're at this point, we're going to read, say maybe an integer value. Can't see the pen, read. Okay, we've read 4 bytes, so we're now 4 bytes forward in the file. The next read, maybe it's another integer, another 4 bytes. but this read get position is tracking where we're reading from in the file. Likewise, every file that is open for writing is going to have this kind of idea of a pointer too. It's going to be a write put pointer, which is going to track where, if we're going to insert into that file, where the characters or binary is going to get placed. And if we're just writing kind of sequential writes to our file, it's going to move as we're adding contents to the file. So if we write that first integer object, 4 bytes are wrote out from the beginning of the file. So our write put position would be 4 bytes forward, and then the next write to the file would pick up at that point and write whatever it is we were looking to write to the file. Now here's where things get fun. We can essentially set either that the read get position, or we can set the write position. So if we're just reading, this is kind of moving, but we could go back, we could specify a specific place to read from, we could specify a specific place in the file to write to. How to set the position of either the read get position or the write position is going to be through their corresponding seek functions. So every file stream is going to have seek G, which is going to allow us to move the read get position within that file. So if we say fs.seekg, and notice here I'm specifying this on a F stream, which has bidirectional input output. So fseekg is going to move the reading position 5 bytes from the beginning of the file. So we're going to offset into that file 5 bytes. Any reads that are going to take place are going to be from that point. Now, this is only governing where we're reading from. If we want to write to that file, we have a different pointer. So I guess this can be read, this can be write. They start out when we open it at the beginning of the file, and then as we're doing operations, they kind of move. We can set that read explicitly to say 5 bytes from the beginning of the file. We could also move the writing position, say 1 byte from the beginning of the file. Then any writes to the file would essentially be based off of this pointer. Any reads from the file based off of this one. So with all of this in mind, let's go ahead and just run through a serializing, deserializing, and binary format example, hopefully reinforce some of the concepts that we've talked about here in this lesson.